We're going to talk about the Poisson probability distribution. This is a different type of a discrete probability distribution, similar to the other discrete probability distributions as the binomial probability distribution and then the discrete probability distribution in general that we learned before. In the Poisson probability distribution, there are 4 requirements. The first is that the random variable x are occurrences over some sort of interval, and we'll talk about that in a second. The second is that occurrences are random, the occurrences are independent, and then the occurrences are also uniformly distributed over the interval. So what we mean by independent is that the probability is not going to change for any one of these occurrences over the interval. And then also, the uniform distribution is important as well. Now, let's talk a little bit about the interval. We can think of the interval as a unit of time. Maybe it's hours, minutes, days, seconds, or whatever, or years. Or we can also think of it as a unit of area. What we're going to assume is that, let's say your interval is 2 hours, and you want to know the occurrence of selling 5 Big Macs in 2 hours. So let's say you're a manager at McDonald's or whatever. We're going to make the assumption that selling any Big Mac over those 2 hours of that interval could happen at the beginning of the interval or at the end of the interval. So there's no predisposition that you're going to sell these Big Macs at the beginning or the end. It's going to be equal opportunity all the way across the board. Same thing for the area as well. We can think of how many chocolate chips are you going to have in a chocolate chip cookie. And what we're assuming is that those chocolate chips could be in anywhere in that chocolate chip cookie. They're going to have a uniform distribution. In other words, there's no predisposition that you're going to have all the cookies at one end of the cookie and so on and so forth. Here's the formula. We have P of x is equal to mu to the x, e to the minus mu, all over x factorial. Now, first of all, mu represents the mean. And specifically, when it comes to a Poisson probability distribution, it represents the mean number of occurrences in the interval. X represents your random variable or the number of occurrences. E is a constant, and that is Euler's constant, named after Leonhard Euler, who was a Swiss mathematician, and then he was later the mathematician to the Tsar of Russia in the 1700s. E is a number like pi. It's a transcendental number. It's 2.71828. Goes on forever, doesn't repeat in any pattern. Now, your calculator is actually programmed to have E in it. What you want to do is you want to look for the button on your calculator that says ln, and then you want to do second ln, and then that's going to give you e to the x when you're typing this into the formula. You can also use StatCrunch to make this happen, and that's in a separate video as well. Let's look at an example. Let's say that on average, you have 17 chips in a cookie. And you want to know what's the probability that in a certain chocolate chip cookie, you have 20 chips. So we're going to go to mu to the x, so we're going to do 17 to the 20th power, e to the minus 17th power, and then we'll divide that by 20 factorial. Now, as I said before, we can do this on StatCrunch, or we can just type it into our calculator. You want to make sure that when you're doing it on your calculator, that you want to use the negative sign for this and not the minus sign. And that negative sign is located on the bottom row of any graphing calculator. You don't want to use the minus sign, the operator that's associated with it. I'm going to divide by 20 factorial. And I'm going to get a probability of 0.0692. Okay? We can also say that Maine is a safe state. And let's say that on average there are 16 homicides in Maine per year. So let's say what's the probability that on a certain day, one person there's one homicide in Maine. First of all, we have to figure out that our mu here is actually going to be 16 divided by 365. And for most of our questions with some probability distribution, we're going to have to do a little bit of work to get the mean. We know that there's 16 per year. We want to know what's the probability that there's one in a day. So we have to make sure that we do a little bit of work to make sure that we use the correct mean in the formula. So now we're going to have 16 over 365 to the first power, and then we're going to do e to the minus 16 over 365 all over 1 factorial. So we're going to do 16 divided by 365 times the second natural log of minus 16 divided by 365. That's all I have to type in. 1 factorial is just going to be 1, and I'm going to get a probability of 0.041096, I guess. Okay. Again, you can use StatCrunch to calculate all of these things. Now, if we want to do a range of usual values, we use the same range rule of thumb that we had before. We do the mean, plus or minus 2 times the standard deviation. The standard deviation for a Poisson probability distribution is the square root of the mean. So let's do our range of usual values. The square root of our mean before is, so that's the mean. Oh, we're going to use 16 over 365. So the standard deviation of that is going to be 0.209. And then our mean was equal to 16 divided by 365 is 0.043, I'll call it 4. So now to do our range of usual values, we're just going to do 0.044 plus or minus 2 times our standard deviation of 0.209. So that's going to be 0.044 minus 2 times 0.209. That's going to give me negative 0.374. And then that's going to go all the way to, I'm going to do the mean plus 2 times that standard deviation. I'm going to get 0.462. What this just means is that 0 is not unusual, which is great for Maine because we want to make it the usual is that we don't have any homicides in a given day. If we have 1 or 2 or 3 or any others, then that is going to be an unusual event because that's outside our range of usual values.